We are live and continue solving our challenge. So let's go to the neetcode and let's check what we left. So we left with the next task, find duplicate number. Okay, so let's check. So we given an array of integers. Wait, is it linked list? Why is linked list? Okay, so let's go. We're given an array of integer nums containing n+1 integers, where each integer is in the range 1 to n. There's only one repeated numbers, and nums returns the repeated number. You must solve the problem without modifying the array nums and using only constant extra space. All right. So here we have a specific constraint. So we have an integer of nums contain n+1 integers, n+1 integers, and we have to return there is only one repeated number in nums, so we should return repeated number. Okay, so let's think about constraints. So I expect that the length of this number would be quite big, from 1, let's say, to 10 in 5 power. Yeah. Then our nums can be values can be from 1 to 25 power, right? Because it's logical. All right. So then what we have next? Then it's not sorted, and we see that from this constraint, it's not a squared solution. Then let's think about test cases that we can have here. So for example, if we have 1, 2, 3, you have an array like 1, 2, 3, 4, 5, right? And then 3. So result would be 3 here. So there is only one repeated number. So we have always this repeated number, right? Okay, so in this case, what we can do, we also cannot use space, should be constant. So we cannot use any extra space here. So no recursion calls, no storage in the map or in the set. So we need to use somehow a linked list. Linked list we cannot actually use because it's another storage as well. And there's only one repeated number. You must solve without modifying the array. Okay, so we also cannot modify array, and we also on constant extra space. Okay. All right, so we cannot use modification here, but we need to find somehow, and it's not sorted, to find the duplicate number. So how we can do this? Let's think. And here we have like multiple duplicate numbers. Okay. All integers appear only once, except for precisely one integer with 2 or more times. Okay, so we have some integers that appears 2 or more times. So how we can do this? How we can roll? Okay, follow. How can we prove that at least one duplicate numbers must exist in numbers? Can you solve the problem in linear time complexity? Yeah, so in linear time, So n log n, it's one option actually how we can solve it, because we can just sort our array, right? So we can use some sorting algorithm to sort actually this array with constant space. So let's think 2 pointers, binary search. Bit manipulation. Yeah, binary search we actually cannot, because we don't have here. We don't have here. How it called? Okay, so you must not modify because it's certain. Yeah, that's true. And because the problem is set, all the in number appear only once. It should be updated. Okay. All right. So let's think how we can L sort without sorting. So maybe what we can do here. Actually, if we have this number n, right? N. So we know that we have n values here. So it's like 1, 2, 3. So here we have 6, right? And if we have our, so we can actually, and we know that they are increasing. They are increasing here. So arithmetic progression would be here. We can understand, like, if we have something like this, so we know that it's arithmetic progression, so value here is the same. So we can take like 6, 5, 3, 2, 1, 5, 4, 3, 2, 1. And then like 7 minus 1, it would be 6. 7 minus 2, it would be 5, and so on. So maybe what we can do, we can just n multiply by n minus plus 1, 7 multiplied by 2, right? 7 we multiply by 2 and divide, yeah, 7. So 7 we can multiply how much? 6 times, and divide all this by 2. And the result here would be 35 divided by 2. Divided by 2, it's not actually the number. Yeah, so because here, okay, so we have 5 plus 5, 10, 15, it should be 21. By 6, not by 5. So 7 multiplied by 6, it would be 42. And divided by 2, it would be 21. Right, so we have arithmetic progression here for this one. But here, the result is different. So the result is 10, 15 plus 3. It would be 18, right? And now what we can do, like we can just 21 minus 18, it would be our result. But the problem here, for example, so here as well, like we can solve it if we have arithmetic progression here. We understand if we will calculate 6 multiply by 5 and divide by 2. So 6 multiplied by 5 is 30. We divide by 2, it would be 15. And here the result would be 12, right? Is it correct? 1 plus 5 plus 2, 12. Yeah, it's 3, but it's not correct. Yeah, so probably arithmetic progression would not work actually for this problem. So let's think about another approach. Do we have some hints? Because I think it's quite complex here. It's quite complex, so certain night approaches. Okay, 1, 2 loops. Yeah, 2 loops when started would not work. Then hash. Yeah, as well. So it's then making visited value within the array. What does it mean? We probably modify array here, right? Yeah, so here we modify array. Sort, we can sort them. And again, yes, index sort. It means that you resorted the array. And binary search. Yeah, but by binary search we need actually sorted thing, no? Okay, so let's think about binary search, how we can sort them. So we have low and high. Okay, mid. We find some mid value, count 0, and then we do a for loop from 0 to length, and if numbers. Okay, so here, if number I is less than count. Okay, so we actually calculate how many values do we have count, and then remove our mid. Yeah, so this one is actually a very interesting approach. Fast, slower. Okay, while slow not equal to fast. How it works, interesting. So we have slow, fast. Slow equal to 0 and fast equal to nums I. Yeah, I'm not sure that I understand this fast slow pointer. Linked list cycle 2. The key is to understand how to read the input array as in linked list. The array 1, 3, 4, 2 is an example, so the index of the array is 0. Okay, we can map the index to the nums, the start from nums as a new index, so on, until the index exceeded the bounds. Okay, if there are repeated numbers in the array, take an array as an example. So we have 0, 1, 3, 2, 3, 2, 4, 2, similar as linked list is like this. Okay, so we actually can solve it with, let's solve it slow and fast, and while slow not equal to fast, what we can do actually, so fast can be like this, and if nums length equal to 1, we return nums 0. Otherwise, we have slow and fast pointer. So if slow, if nums, let's say like I and j. And what we do here, if nums and I equal to nums and j, we return nums and I. Otherwise, we just update I with nums I and j with nums j. I'll end return like -1 because we should never go here. Time limit 1, 3, 0, then 2, then 2. How I solve it? Interesting. Yeah, so I see that I sort them and then just find binary search here. So it's definitely not correct. So I think this one is correct. Okay, so let's check. Let's check with, first of all, Java. We need to sort somehow. Visualization. Okay, so let's implement this operation here. So we have slow pointer, it would be nums I, and also we have nums j. And here, while I not equal to j, we do these two operations, right? And if it's equal, we actually break, right? So we do this one. Then num 0, and here nums 0. So we actually break. So here we have two similar cases. Then we have slow, we update to nums 0 once again, and while slow not equal, slow2. Okay, so we need slow2. Slow is not equal to slow2. We do the same logic here. Oh, yeah, so it would be k. So while I is not equal to k, we update our I and k, and we update our k, and then we return I. Okay. So what's the difference we have here? Thank you. Yeah. I'm not sure that I actually understood this. Ah, okay. So the main difference here. Yeah. So the main difference is this one. But I don't understand why it doesn't work. Why this works, but it doesn't work. So this works. Yeah. It doesn't work. So let's check. Do we have some an old implementation here? For example, this one. No, it's the same. Yeah, the same. Okay, start cycle detection implementation. Locate the start node of the cycle and duplicate number. Okay, so we first. I still don't understand. Okay, so I need to watch the video of this algorithm, but yeah, it looks like quite complex for me. So let's mark it as done, but yeah, quite complex. See you tomorrow.